Okay, I wanted to give a little update on part of the project. And so I'm looking at some data here, and you probably have a lot more years than me, I hope so. And I want to insert the trend line. There was already a video that we linked that showed how to do this, but I'll go ahead and do it. It's pretty quick. I'm going to insert a chart, and I'm going to put my first scatter plot here, and then I'll go up here to advanced edit, and I'm going to put the linear trend line on. I'm going to update the label so that I see the equation, and there we go. I'm going to go ahead and do this again, this time with the exponential. So I'm going to insert another chart, scatter plot. I'm going to put it in, drag it over here, and this time I'm going to change it to the exponential one. And I want to see the equation again. Okay, so there we go. We've got our 2. Actually, let me make sure I can see the equation over here. I can't. If I make this a little bigger, well, it's being obnoxious. There may be an easier way to do this, I'm not sure. But if we make this bigger, now I can see the whole equation. Okay. So what I wanted to talk about was number 7 and number 8. Number 7 asks you about which one seemed to fit the data the best. And so on these, it's going to be really kind of hard to tell. Lots of them are going to be pretty close. So you can even say something to that effect if you want. Especially now that I've zoomed this one, it looks a little different than the other one. So it's hard to tell even more. If I shrink it back down, yeah, I don't know. It's really hard to tell on these which one fits the best. The exponential maybe is a little better on this one. It's pretty hard to tell. They're all probably going to be pretty good on mine because I don't have very many data points. You probably have more points. But you can answer number 7 just right here on your Google Sheet. If you just type number 7 and then say, the exponential model appears to be slightly closer to most points, or something like that. What I really wanted to talk about was number 8. Number 8, you're asked to do some predictions. And it said for either 2018 or 2020, so that might be like 80 years or 84 years down the road for you. So if you were to put in like a number 8 here, and then you're supposed to do it for the linear model, the quadratic model, and the cubic model, and the exponential model. Okay. Let me just show you how to do this. The linear model is negative 0.0022x plus 3.97. So what you want to do is equals negative 0.022. And then where it says x, you just want to enter this 80 that you'd put in there. Just click on that cell, and plus 3.97. And there's my prediction. And then if you wanted to do another year, like a few years later, maybe 20 years later, I forget exactly what that project asked for, you can just copy paste that formula down, and you can see it will predict again the time. You can do the quadratic and the cubic the same way. Just wherever there's an x, just replace it with this cell name right here. The exponential gets a little funky. And that's because the formula looks a little weird. Again, let me blow it back up. The way that they give exponentials here is a little different. This is a number, like 3.97. And then this is a power of e. We talked about e in this chapter a little bit. It's the base of the natural log. So you might have seen it in some of the exponential functions, but really not very much. But then this capital E is scientific notation. So really what's going on here is this all the way up until the x is a number, e to the negative 0.5894 times 10 to the negative third. And then this x is really an exponent over here. So it's a little funky. But what we can do, and the way to type this in, is equals 3.97. Oh, let me get back over here. Equals 3.97. And then for the E, use EXP. And then in parentheses, we want the rest of this that we had over here, which is negative 5.894 times 10 to the negative third. So negative 5.894 e negative 3. And then we want that whole thing to the x, and we'll replace the x with our cell over here with the 80. And apparently I messed something up. Oh, we need 3.97 times. So there you go. You see our exponential model. And then I could, again, copy it and paste it down one, and it'll update with the new year. And so there's our exponential prediction. So you can take a look at this code and you can copy it and get this done. So thanks. I hope this helped.